I'm so honored to be with you to communicate academic questions and ideas. The title of my academic presentation is Semantic Modeling Supports Integrate of Concept Decision and Knowledge. First of all, I want to introduce myself. My name is Jingyi Li. I come from Beijing Institute of Technology, Beijing City, China. My presentation will include these 4 parts. First, the introduction. The product design process is a design activity with design logic and scientific principles, such as automatic design (CK series). With the increase in product complexity, traditional document-based design methods will produce a large number of documents in different formats and variants, and it is difficult to ensure the consistency of design information in different documents. To construct a design framework for the concept development and design making for product development, design series are often used to capture frame the topologies between concepts, design making, and knowledge across different domains. Currently, semantic modeling is the basis of describing product information using models and shareable data. It often contributes to integrating domain-specific knowledge and development solutions with design frameworks. Currently, CK series has received wide attention for integrating concept design and domain knowledge. CK series is a new type of product design method. Through the dynamic mapping between the concept space C and the knowledge space K, the process of the project generation is expanded. And the CDK theory is based on CK theory and introduce decision space as the engine for the mutual transformation between space C and space K. But in CDK theory, space C finally obtains a satisfactory solution through divergent combination expansion, focusing on the design process. Space D determines the expansion direction of space C and space K through a series of decisions, focusing on the mathematical analysis. Space K through deduction and combination acquire new knowledge, focusing on knowledge management and reasoning. Then, how to achieve a unified description of the 3 heterogeneous space is a challenge. Aiming at the above problems, a method of semantic modeling of 3-dimensional space based on Tama language is proposed. Tama is a unified modeling language development based on GOPPRE math modeling method and M3 to M0 modeling framework. From highly abstract mathematical models to construct math models and system viewpoints respectively, and it can realize a formal description of the heterogeneous space. First, use Gamma to construct the meta models of space C and space D, respectively, where space C, based on SysML modeling language and requirements, function, logical and physical, 就是 RFLP design process organization modeling. Space D, organization modeling based on PI decision-making workflow and decision-making methods based on decision-supported problems. Space Key, based on OSLC specification and RDF metadata to realize the integration and unified description of knowledge. Space C builds models based on requirement, functional, logical, and physical architecture frameworks, and the model based on the 9 types of SysML diagrams can clearly describe the requirements and program design information on functions, behaviors, and physical structures. And the key elements of the non-space C graph based on GOPPRE meta modeling method are as follows. Space D involved various types of decision-making, such as the choice of the schemes and the balance of different design goals. Decision support problem technology provides a specific implementation method for Space D decision-making problem solving, and the PX decision-making workflow can realize the description of the decision information in different stage and different granularity in Space D. The key elements of the Space D graph based on GOPPRE meta modeling method are as follows. The knowledge in Space Key is the integration and expansion of knowledge in different disciplines and fields, and exists in different forms. Open series for life cycle collaboration (OSLC) can integrate data in different tools. Standardized resource in the forms of URI and use RDF for unified expression and description. A case study of a unmanned detection vehicle design is used to evaluate the proposed approach. The semantic model of the Space C and Space D is built using a domain modeling tool, MetaGraph, and the OSLC adapter for the Space K is designed and built by an OSLC designer tool, DataLinks. Through the above process, 4 design schemes for unmanned vehicle mobile platform subsystems were generated, and decisions were made. The results show that scheme 1 should be selected for the next design. The last contribution. Compared with the existing research, the contributions of this paper are as follows. The proposed semantic modeling approach able to formalize candidate concept solutions and the decision-making process using a unified semantic representation through Gamma language. OSLC specifications are used to capture the information from knowledge set is used to configure the karma models. Through all the semantics modeling techniques, the CDK theory is realized to support the product concept development and decision making based on the given knowledge. That's all. Thank you.